All right. This is the equation for a circle. In this equation, it is the same thing as the distance formula, but the distance is being consistently have to be this exact length. So H and K are going to be the center of the circle, and R is going to be the radius. So if I were to give you, and X and Y are actually coordinates that are on the circle. So if I were to tell you the equation looks like this, x plus 2 squared plus y minus 7 squared equals 81, you could figure out that -2, 7 is the center of the circle, and the radius is 9, because something squared made 81. So I square rooted it. All right? When you pull them out, they seem to change signs when you pull them out because the equation has a negative already there. So the only way that this could have become a positive 2 is if I put in a -2. So I took that out. The number I put into K was 7, y minus 7. So 7 is the number I put in here, and that's why I pulled out a 7. And there you go. If I give you a coordinate to check if it's part of the circle, well, reversing this process is also very easy. You just put the numbers in the equation, right? In this equation over here. So let's say I want you to check if a certain number is part of this circle, right? So I'll go 2, 5. I want you to check if 2, 5 is part of this circle. So you plug it in to this equation. 2 plus 2 squared plus 5 minus 7 squared equals 81. It has to equal 81. If it doesn't equal 81, then this is not one of the points that are on this circle. So this would be 4 squared. This would be -2 squared. This would be 16 plus 4. That equals 20, which does not equal 81. So this is not on the circle. Pretty simple equation, okay? This is the distance formula, but R is consistent because the center of the circle and anything around the circle has to be equal distance from the center. That's a horrible circle, but you know what I mean. Oh, next. Arc length, arc sector, arc segment. We'll do each one for this section right here. So let's say I'm talking about the arc length. So from A to B. So that's 70 degrees of the whole circle. So 70 of 360. Okay? 70 of 360. Then you multiply that times the area of the whole circle, which is pi r squared. The radius is 3. And that's it. Okay? If I want it in terms of pi, this would be 70 over 360. So it would be 7 over 36 times 9 pi. Then I would multiply 7 times 9, and I would get 63 over 36 pi. And then this answer would end up being, let me see, divided by 3, so it would be 21 over 12. And then these are both divisible by 3 again. So this would make 7 over 4. And then I would just put pi next to it. This is in terms of pi. I did not multiply with pi. I just left it like that. If they do not want something in terms of pi, you would simply multiply this by 3.14 and you'd be done. All right, so that's the arc length because we're talking about length. Actually, that was the area of the sector. I'm sorry, area of the sector. So I found the area of all of this. So now we're going to do arc length. So it's very similar. 70 over 360, because still I'm only doing 70 of the whole 360, times diameter, pi. Okay, so same thing. I'll leave it in terms of pi so we can do it here right now. I'm going to cancel that out. 7 times 6 is going to be 42 over 36. Both of these are divisible by 6. So it's going to be 7 over 6 pi. Okay, and that's the arc length because diameter pi is the circumference around the circle. Pi r squared is the area of the circle. Now, area of the segment. So let's say I just wanted from here to there. And I just wanted you to find me the area of that little piece I shaded in. Okay? That's going to be the segment. So that's the area of the sector minus the area of this triangle. So the area of the sector we have 7 over 4 pi. So we're going to have to actually multiply that to figure out what it's going to be. So 7 over 4 is actually 1.75. So let's actually multiply that. So 3.14 times 1.75. That's going to be 20. That's 7. That's 15. That's 28. That's going to be 9. 21. That's 4, 1, 3, 0. 15. That's going to be 19. That's going to be 4. That's going to be 5. And that leaves me at 5.4950. So we'll take away the 0. Unnecessary. So we're left with that. So now we know the area of the entire sector. So now we have to find the area of this triangle. The area of the triangle, now I'm going to draw it over here so you see it. It's a triangle like this. This is 70 degrees. I know that this side is 3 and that this side is 3 because they're both made up from the radius. So this is an isosceles triangle. So if this is 70, these two have to be identical. So 110. They have to create 110. So they're both 55 degrees. Okay? All I have to do is figure out the height of this. Okay? I also have to figure out the base of this. Okay? And then I'll know. So let's do that. I have a calculator somewhere here so I can do it in front of you guys. All right. It's right here. So we are going to do, here we can do SOHCAHTOA. So this is going to be 35 right here, and that's going to be 55. So let's use, for this one, let's do opposite. Which one has opposite? Opposite over hypotenuse. So we're going to do opposite over hypotenuse. So 55 sine of 55 equals x over 3. Right? So we go in here. We're going to multiply by 3 on both sides. A lot of people ask me, how do you type this in the calculator? You literally type in what you're saying out loud when you say this. So this is 3 times sine 55. Done. And is 2.457. So I'm going to say 2.46. So I know that the height is 2.46. So the height is 2.46. So now I'm using adjacent and hypotenuse. So it's going to be the same formula, but cosine 55 equals x over 3 again. So this formula is going to end up being cosine, or 3 times cosine 55. And that's going to give us 1.72. So 1.72. So 1.72 is half of the base. So we're going to multiply that by 2 and actually get the full base. So the base is 3.44. So 3.44. So we're going to do 2.46 times 3.44 divided by 2, and we get 4.23. So 4.23 is the area of just this little piece here. 4.23. No, it's actually the area of the triangle. I'm so sorry. That's the area of the triangle, and I have to subtract it from 5.495. So 5.495 minus our answer that we just had, and that is 1.2638. That's horrible. 1.2638. There's our final answer for the area of just this little piece right here. A lot of extra work. It doesn't happen often, but it does happen. All right. Tangent to the circle. So if something's tangent to the circle, it is perpendicular to the center of the circle. So it should be a 90 here. Let's check if that's correct. I'm now checking if this is tangent to the circle. If this is 30, that's 50, that's 80. That would make this 100. So it would not be. So that would prove that it wasn't tangent. So let's pretend it is tangent. Let's actually put a 40 here. So if this is 40 and that's 50, this one has to be 90. So now it is tangent. Now, knowing this is tangent, okay, knowing that this is a 90-degree angle can help us solve for x as well. Okay, so what we just did was prove that AB, the line AB, is tangent to the circle using the 40 and the 50. I don't know why the 30 was there. Like I said, the example I looked up was a no, and you were supposed to go on, but I want to keep on going. So that's a 40, that's a 50, that's a 90. All right, so now we're going to figure out what x is. This is a right triangle. I can use Pythagorean's theorem. So it's going to be a squared plus b squared equals c squared, which is x plus something. X plus 3. How do I know this is 3? Because it's also the radius squared. Actually, we can actually just figure out the length of that side, which is going to be easier. So we'll just figure out the length of that side as c squared. So this is going to be 9 plus 49 equals c squared. This will make 58 equals c squared. Square root of 58 equals c, because that's how you remove the squared. We live with that. What's the square root of 58, you ask? Let's find that out. The square root of 58 is 7.615, so let's do 7.62. So 7.62 is c. So this entire thing is 7.62. This piece is 3, so I'm going to subtract the 3 from this, and we're left with 4.62, and that is what x is in this example above. Now, those are all the examples I can think of. Remember, tangent means it is perpendicular to the center of the circle.